The factor theorem. So if a polynomial f of x is divided by x minus h, remember, the remainder is f of h. That's the remainder theorem. But if f of h was 0, that means that x minus h would be a factor of f of x. Similarly, or conversely, x minus h is a factor of f of x if f of h is 0 in the remainder theorem. We can write f of x as f of x equals x minus h times q of x, where q of x would be some quotient. Obviously, usually that's plus remainder, but there's no remainder. Example 1. Show that x minus 4 is a factor of this. And this comes from HSM page 16, question 2. We want to show it's a factor, then we can, if f of 4 equals 0, then x minus 4 is a factor. So working out f of 4, we've got 2x4 minus 9x cubed plus 5x squared minus 3x's and then minus 4. And we're substituting 4 into the polynomial. So we drop the 2 down, 2 4s is 8, 8 minus 9 is negative 1, 4 times minus 1 is minus 4, 5 minus 4 is 1, 4 times 1 is 4, 4 minus 3 is also 1, 4 times 1 is 4, 4 minus 4 is 0. Since f of 4 equals 0, x minus 4 is a factor. Notice for this question, just a few points, okay? You have to write x minus, since that's equal to 0, x minus 4 is a factor. If you don't write that, you've not got the marks. You can't just do this and say nothing, okay? Given this polynomial, we have to show that x equals minus 7 is a root of f of x equals 0, and then hence fully factorise it. So it's exactly the same question, just worded slightly differently. If we to show that it's a root, then we can show that x adds 7 is a factor. If x equals minus 7 is a root, then x plus 7 is a factor. So f of minus 7 would equal to 0. 1x cubed. We've got 0x squared. Notice that there's no x squared. Minus 37x's and 84 in the end, and we're substituting minus 7 into the polynomial. 1 times minus 7 is minus 7, minus 7 and 0 is still minus 7. Minus 7 times minus 7 is positive 49. 49 take away 37 is 12. 12 times minus 7 is minus 84. 84 minus 84 is 0. Since f of minus 7 equals 0, x plus 7 is a factor. So x equals minus 7 as a root. The next part of the question asks us to then fully factorise it. So notice we found our root, but this bit here is now our quotient, q of x. So we should be able to factorise it nice and simply. So f of x equals x plus 7 times x squared minus 7x plus 12. Because our quotient is given here, x squared minus 7x at 12. Now we need to check if we can factorise that. It should be nice and simple to factorise. We've got x plus 7. Two numbers at times together to make 12, but add or take away to make 7. That's 3 and 4, so minus 3, minus 4. Show that x minus 5 is a root of this polynomial, and then hence we factorise the cubic. X equals minus 5 is a root. minus 5. We have got 2x cubed, 7x squared, minus 9x's, and plus 30, and we're substituting minus 5 in. So we'll drop the 2 down. 2 times minus 5 is minus 10. Minus 10 and 7 is clearly minus 3. Minus 3 times minus 5 is 15. 15 minus 9 is 6. 6 times minus 5 is minus 30. 30 and minus 30 is 0. F of minus 5 equals 0. So x equal to minus 5 is a root. X plus 5 is a factor. Also, for the purposes of these questions, I always say that that's a root and that's a factor, because the question will either ask you prove that this is a root or prove that this is a factor. So you don't miss one switch, just put both in and you'll have answered the question. If you miss the statement, you miss the answer in the question, so you lose a mark. Now it says, fully factorise the cubic. That's my q of x. So we've got x plus 5 is a factor, times 2x squared, minus 3x plus 6. Go ahead and try and factorise it, or you could just check b squared minus 4ac on this part. Let's do that instead. B squared minus 4ac. Well, that's minus 3 squared minus 4 times 2 times 6. 9. 4 2s are 8, 8 6s is 48. 9 minus 48 is clearly negative. So since that's negative, we've fully factorised it, and there's the final answer. This has been Clever Maths. Today we look at the factor theorem, which follows on from the remainder theorem, noticing that if we know f of h equals to 0, then we've automatically found a root, and therefore we've automatically found a factor x minus h.